He lost.
Okay, that's fine. All right, network. This is second class of networking. Probably we'll finish up networks one more lecture, or 1.5 or 2 at most, which is maybe first or second week of April. Today is the lecture before your midterm exam. Next week is your midterm, right? And the following week is your spring break, so there is no class. So next 2 weeks, we do not meet face to face. So if therefore anyone of you are sad, come and see me. Or if we can meet. Well, yeah. As you might know, we'll have a cyber skill competition. So competition will, the kickoff meeting will be possibly the Saturday right before your spring break. So I guess today is the 16, 17, 18 plus, wait a minute. So next week is the last, probably next Saturday. Yeah, next Saturday. Not this Saturday, but next Saturday will be the kickoff meeting. I will make an announcement. So I want you to have that. I want you to form a team. All right? Can you do that? You can make a one team to develop any attack or defense software packages, so that you can take it to your interview. 100% of the students who participated successfully in this competition got jobs by the world-class companies or federal entities. All right. So if you want to join the top-class companies, this is one of the promising gateway. Okay. So utilize these opportunities. Once we set up a kickoff meeting, then usually it'll last till the end of August. So throughout whole summer we meet every Saturday, most Saturdays here, and work together. As I made the announcement, we together learn. What did I say? Over there, right? I made that. So keep that in mind. So I strongly encourage you to do that. Another thing is the homework number 4. I'm going to recommend your internship and employment to Lohid. That is one of the top consulting companies. Based upon grade, I'm going to recommend 2 or 3 students. If I don't see any good implementation, then I will say to him, no, maybe next time. All right. So still possible. I'm going to grade, not wait for long, maybe by this weekend. if you revise your work before weekend, then send it to me before I recommend anyone. If you think you are the person, then please submit it and then text me so that I can include your name in the list of potential candidates. So two things that I made announcement, special announcement. Okay, socket programming. Anybody has done socket programming?
No.
Oh yeah,
Scanning ports and FTP to connect. I want to connect to the FTP server.
Did you do that in coding, or I know you're using some of those?
The buffer overflow.
Right. Is it programmed by you, or?
I used the socket. I installed the socket.
Okay. Then.
Connect to the
Okay. Then you don't need to take this. You may leave
so
if you want to.
the browser. Okay, so you say you might recommend a student to a company. Okay, based on their code, their recommendation. You want us to do it like your way or our way? Like
What do you mean by your way, our way? It's the company's way.
companies will understand.
So the company will make decision.
What matters at the end is it the code or the outcome? Because
Everything.
because your code seems a bit complex.
I want it to be the one that I did.
Show us.
If you did it, then I think you're good.
The way
You could do it different way, but then that is not really the well. Do your best, okay?
because of course your way is more like what the company is looking for.
No, not necessarily. I'll see. Okay, so don't be afraid. Do your best and see what I can do and see what they can do. I'm not going to screen you much. Okay, if your work's good, and if I have any question, then I can call you. Okay, and ask question about coding. So if you can answer, then maybe the question that you may receive at the interview. Anyway, you need to, right? So do not. You have to make sure that you fully understand the code that you submit. If you are selected to the interviews, okay, you need to fully understand your code so that when they ask you, you need to answer completely, and your answer needs to convince the interviewer. You see what I'm saying, right? Any other question about employment? So you drove from New Jersey, Brooklyn. When did you move to Brooklyn? I thought you live with him in New Jersey. Okay. I thought he's your or whatever. Okay. Anybody here familiar with Spain? Spain. Have you been in Spain? Cross by swimming, right? Or jump. If you see that, it's very close. An hour swimming. Have you been in Valencia? Balance? Huh? Balance. Valencia? Anybody heard of Valencia? Yeah, Madrid. Madrid is inland, right? Valencia is like harbor, like Barcelona. Barcelona is a little bit near to France, and Valencia is the south, so close to Morocco or Mali. So I'm going to make a presentation for Valencia in May. So I've never been in. In May?
Yeah, the weather is good.
Very good in May. I hate weathers in Europe in summer.
Europe?
Yeah, all Europe in summer, like April. Sticky, humid. Same thing in Morocco. No, very hot. I've been there in July, late July. Very, very hot. Anyway, okay, circuit programming. This is very, very useful to you. So we'll do hands-on, particularly server and client fashion. So if you want to look for some of the references, as I introduced to you, Network Sorcery is a very good website. We may use this next class. Okay, next class means first week in April. You know that, right? Next class. Next meeting is virtual, not face-to-face, for your midterm exam. So you don't need to come, but you can come if you want to take your midterm exam here at school. Or you can take it at home. There are 3 possible time slots. I assume that you all can accommodate. So you can choose one of those 3 suggestions. So when you come back in April, then we'll do sniffing, programming for sniffing, network sniffing, but not completely, because 1 hour of sniffing program is not enough, because we need to take care of a lot of things. But I can open the door for you to play in that sniffing areas. If you do that, it is not just for sniffing, but if you do some extensive work, then it'll be a spoofing. Spoofing is real expensive work, right? And also very, very interesting. Interlayer relationships. Packing for packets. Along the layer, each layer uses a layer below. The lower layer adds headers to the data from the upper layer as it goes down. Data from the upper layer can also be a header on the data from the layer above. So it can be added when the data is passing through the network architecture from top to bottom. As packet arrives the destination, then packet is moving up from physical layer all the way up to the application layer. As it goes upward, header can be unpacked so that header information can be seen by a specific layer. So unpacking is a backward. So that is the packet. Then packet reaches the destination by IP address. So what is IP? The characteristics of IP is a datagram based. Of course, TCP uses IP, but typically it is called datagram based. The datagram still rely on IP, not necessarily connection, but by looking at IP, it can reach the destination. Quick connection and then connect. It's not really connection, right? It is IP-based traverse. IP is unreliable. Why? Why IP-based communication is not reliable? Particularly in cybersecurity reason. Delvin might know because he knows Saki programming. Which one?
I didn't understand the question.
Question was here, unreliable.
Oh, UDP?
No, it's not UDP. You're talking about IP.
That IP-based network is not reliable. It's not mine. But it's called like the secure network or virtual private network through the unsecure protocol like IP. And when we establish a virtual network, virtual private network, it could be site to site or it could be site to multi-site. Definitely we have changed the IP protocol.
That is true, but it is not the answer to this question. Mainly because IP doesn't point to a specific hardware. Each hardware may use different IP at different time, which means if something badly created from one of your workstation, next time, therefore, if we want to trace back to that IP, then at that point, IP is being used by some other server, some other workstation. So attacker is not really pointed by IP address. Which means attackers may be able to use any arbitrary IP to attack and then move to another IP and another IP. Then it is not traceable. If it is not traceable, then detection is almost impossible, right? That happens in many cases, right? If you look at server here, then a lot of attacks. I think maybe 10 attacks per minute average. So we know that the IP address where they attack us from. Okay. So by looking at the IP address, we can pinpoint where that IP is used, because that IP is assigned to a specific subdomain. So domain is physically that is known. But within that domain, somebody hook up that specific IP and then leave that subdomain and move to another subdomain and use from a different source, then we do not know they are the same person, same attacker, right? We simply know that, which countries, country by country, right? At least 50% of the attackers are from China, Russia, right? But it's not necessarily they are the real attacker. Maybe somebody stepped in China and final attack from China, so that many people blames. Oh, China is maybe or maybe not. That is unreliable, right? In what way that we can then see and point out a specific attacker if somebody uses his own workstation? I already gave you some hint, right? His own workstation. Then each workstation has a unique ID, which is called MAC address, right? MAC address. So if you will link MAC address and IP together, then very nice. But current IP protocol never pick up MAC address in any of that header files. That is designed that way. Okay. IP address uses 32-bit addresses, which means 4 bytes. There's a 4 bytes IP address. But now we have a 6-byte IP address, right? IP version 6. Then a lot more IPs can be assigned. And also we can think of UDP and TCP. If we have IP, through that IP we might have UDP or TCP. Then what is UDP? It is also known as datagram based. So that is connectionless, unreliable, and can broadcast. Therefore, we do not need to know each individual receiver, right? There's a broadcast. Application usually message based, so no transport layer retries. What do you mean by no transport layer retries? We do not really connect through a specific port and hold that port throughout all the communication. Process identified by the port number. As far as we know port number, then we can get in. No connections. Services live at the specific ports, usually below 1024, but not necessarily. In our hands-on, we do not need to. TCP, connection-oriented. So 2 endpoints can be virtually connected. It is reliable. Application needs no error checking. Application layer do not need, because network layer take care of that. Stream based, that is possible. It's not DGRAM based, it's stream based. and possessed identified by a port number. Services live at specific ports. Port means, what is port? So we're talking about ports. Port number, ports. Ports is nothing but sockets, right? Like we have sockets that electric power outlets and telephone lines and sockets for the bulbs. So socket is endpoint of a connection. Socket programming is uses IP and port number. Okay. Long time ago, when I was a student, anybody who knows the socket programming can make, at that time, 6-figure salary. So average computer science salary is about half of those, so double. Socket program, why? If you do, by the end of today's lecture, you will know that, socket programming is easy. But 20, 30 years ago, socket programming was not this simple. There's a lot of steps that you have to specify with some valid statements. Although it's not guaranteed. So that happens. Now, few lines of code can do. You can make a TCP communication, UDP communication. You can do that today, of course. Right? For example, remote procedure calls, RMI, remote method invocations, and all details needs to be done. When I first took Java course in 1995, directly from Sun Microsystems, Java, we call it native Java, right? Native Java programming can be done quick. And after that, distributed Java programming. So a lot of work needs to be done. Distributed Java programming. One of the things that we have to consider in distributed Java programming is RPC, remote procedure calls. But now, it's a lot simpler. You don't need to do much. Okay. Of course, there's still a lot of hassles. Yet it needs to be simplified. Okay. But Python is a simple language that can be handled by importing some packages, modules. We can resolve the problems. In your homework number 4, I think you have how many imports? How many programs imported? I think many programs needs to be imported, right? Are you done, Vishnu? Delvine, are you done?
Yeah.
Almost? Good. What about Peter? Shake? Still shaking? Almost? Great. You don't need to worry about database. As I said, simply use it. If you know it, then very good. But we'll get to that database technology before the end of this semester, right? So you will do much clearer, so that you can add more. See, in the menu, retrieval button is only demonstrated, right? There is a population and creation. The others can be done also very, very quick and very easy, right?
No, thinking there is those
We don't have programming background, but that's all.
I know. That is the reason. It doesn't mean that you don't need to challenge it, right? Yeah, challenge it. If you do it, then I'm worrying about if you leave, because you get an offer. Tomorrow you receive an offer, so that, hey, bye, I'm leaving. That's good for you. That is all reason that I am here, right? Your success isn't my success. Although you don't appreciate anything at all, but by myself, that is my achievement. Okay? So that is the reason I am here.
Because, Professor, you also ask, I mean, you know, you also ask us to implement the scroll bar.
It's color red.
Which one?
Scroll bar.
Oh, scroll.
Scroll bar on the right side.
Uh-huh.
If you open any file,
So we can scroll
that
up
can
and
be
down
Mhm.
to see the
Right.
content. That was in the previous demos.
Okay.
It's in the
I know.
database that you
Oh, yeah.
to implement it, to put it to,
Mhm.
so that adds a lot of work.
Oh, yeah?
I mean, I already did it before, but
Yeah.
just, it's another task to add.
Right. Not in this class, but if you join cyber skill competition, then we can discuss the technical the solutions, and I'm going to work with you. You can expand the work that you already started to meet some cybersecurity. I'm not sure what you can do, but you can think in more creative way. Okay. So I respect your creative thinking. Okay, conceptually, the socket is in this way, socket programming. See, this is a user space, this is an operating system, okay? Everything that you could do at user space is what you could do in your programming. For example, bind, send to, receive from. Those are the language that you can use at the user space, which is nothing but the application layer, right? And then the socket layer and transport layer. Transport for IP and specific ports. Specific ports and IP, all the detailed information can be handled by operating systems. So although you use high-level language like bind, send to, receive from, okay? If you are, for example, here at Mercy, we do not go deeper inside in technical orientation to look for a fundamental implementation. For example, I do not ask you to implement sand tool, right? I do not ask you to implement this sand tool. We simply use the sand tool. But in some other efforts, they may ask you to implement this. In that implementation, they usually use not in Python but in C, right? Then they need to touch buffer spaces, okay? And they need to touch the socket parameters and socket descriptors. They need to look at and touch all specific hardware specifications. Right. It's not. I'm not talking about electrical engineering. I'm still talking about computer science. Computer scientist needs to handle by programming hardware. If your programming has nothing to do with your hardware, then your programming is very high level, very, very high level, right? Who can do that high level programming? Everybody. In next 10 years, it's not the computer scientists or cybersecurity professionals can do, but everybody. For example, English major, fine art major, or dentist, you name it, right? Finance specialist. Everybody needs to know that high-level language. At that point, the computer scientist needs to do the deeper level, which not everyone can do easily, but once you do, then you can improve dramatically. But everything here, everything under this, okay, that is done by operating systems. So right now we do not need to worry about anything about operating systems, right? What we are worrying about is here, this level. As I said, this, and this, okay? Sometimes some other people may need go deeper, so that there is the IP layer and physical layer also. Okay, so deeper and deeper. So we are not going to do that. What is a socket then? Socket is an interface between application and network. Between application and network. Between application and network, there is a big layer can be done, which is operating systems. Okay, so before you leave your system, there is operating systems. So part of the management that can be done by operating system is a network management. So if we say network here, then that is not this network is partly done by operating system, partly done by network interface card and network software packages. what you need to do in your circuit programming is that you need to create a circuit objects, a circuit. So that is an object of why only you two guys? We have 5 people. No, I'm just kidding. Okay, circuit type dictates the style of communication. So we can decide at the circuit programming whether we will do connection based or connectionless. Right? So we can do TCP programming, or we can do UDP programming. Once configured the application, or network and circuits, then application can pass data to the circuit for network transmission, and also can receive data from or through the circuits, send out and receive from. That is possible. 2 types of circuits, right? Circuit stream and circuit diagram. If we use a circuit, this is 2 different types of circuits. If we use a circuit stream, then it means we try to do for TCP communication. If you choose this, then that is the UDP communication. So depending upon the circuit type, you may have reliable or unreliable delivery, and order is really important or may not be. Connection is really needed or may not. Or bidirectional is possible, or simply can send or receive. That's what we are going to practice. Okay. Someone may ask questions. See, if you see these 2 different method, which one is really better in communication?
Depends what you need.
That is the answer here. Because you answer that, but if you do not answer that, then we may say, oh, this is better, because that is order related and connection oriented, that is bidirectional, oh, powerful than the other. Right? The other is less powerful. The question then, why still we use circuit diagram if this is not really efficient?
Because in some time, what you need is not the secureness, it's not the connection itself. What you need is how fast it is. In that case, you need UDP. You don't want to do 3-way handshake and to establish the connection. You just want to send right away, like data transfer. In some kind of services, you need UDP. You don't need TCP.
That is correct. Any other questions? Has any other reasons why do you still use a SOC diagram? He already gave an answer. In general, yes. But we looked at already. in earlier slides, socket stream is good for point-to-point communication. What if we want to do point-to-many, like broadcasting? So I'm the server. I want to send out, distribute the same message to million receivers. Then we need to use DGRAM, right? SOC DGRAM. I don't care if somebody do not receive, but I do care distributing only. Okay, broadcasting, multicasting. Broadcasting is very, very common in social media, right? These days. Social media is not point-to-point communication. It's always point-to multi-receiver communication. And impact is huge. Paramount. That occurs here in the United States already, halfway through. But we already knew the bad impact of social media in South Korea, presidential impeachment. There's a totally from the social media. One of our faculty members came to my office this morning and he says, he read all the items that the impeachments, he said, oh, none of those are really critical why the president was removed. Only because of the social media. But anyway, so it may occur quicker in all other countries. So we have to worry about that. That is the bad impact of the social media. The more you are connected, the more you are vulnerable. Not only infrastructure, but also your thinking. Who can correct you if your thinking process is damaged? Then who fix you? No one, right? How do you know that you are damaged? Particularly, you do not know. No one knows.
You're lucky if you.
Yeah. So that is a future world. That is the bad consequence of IT evolution. Bad consequence. There is a good consequence also, right? But bad consequence, negative consequence. There's a lot of positive consequences, but still bad consequences. There's broadcasting. So social network is broadcasting. If you have a large volume of followers, then you will be a great influence. You are the commander-in-chief in that comrade. So you have your own soldier. In America, do we have internet? Not internet. YouTube. Individual broadcast, so that a lot of followers watch what that person can do on YouTube, so that person posts something on YouTube periodically, so that a lot of followers, they watch their videos. Do we have that? Are you subscribing any of those? It's not really subscribing. Are you periodically looking at some of the videos generated or created by some specific person?
Yeah, of course.
So you do?
Notifications.
Oh, so you do that?
If you are subscribed,
Right. So you do that?
yeah, if you subscribe to his channel, you will receive some notifications periodically and daily, usually.
So that type of, if that person, provider, if that provider does something badly, then that influence will become so negative. Okay. So, each host machine has an IP address as far as that machine is, that host is connected to the internet, right? When a packet arrives at a host, then packet comes into your host through port. So each host has about 65,000 ports. Some ports are reserved for specific applications. Port number 2021 FTP, 23 TCP, 22 SSH, secure shell, SSH.
SCP2.
Huh?
SCP.
Oh, secure copy. But secure copy is there's an application. Huh? Right, that is also.
Because all
No.
of them go through SSH.
Right. So that is SSH. Those SCP or SFTP, other application using still SSH. So port 22. Telnet 23, very, very vulnerable. Still, you can use Telnet, port 23, or port 400. What is port 400? 400?
400?
You can telnet to port 400, then it'll be an email. Okay? Which means you can generate fake email through that port using telnet to send to someone as if you are somebody. It's very simple, right?
Which protocol?
There's a simple mail, SNMP? Simple mail transfer, yes, something like that. SNTP? Yeah. You can practice that.
But SMTP doesn't use 400.
Protocol itself is 400 protocol. That's what we can make blackmail. This is for blackmail. up to 200 ports, they're reserved. 433, 433, you all know that, right? 443, yeah, 443. HTTPS. What else? Any other ports that you know? There are so many, right?
GFTP. GFTP is 69.
And all others, if you set up your own applications, for example, if you set up Oracle, then you can choose one of the port numbers from this. So your Oracle may go through that. Okay. In our hands-on lab today, you can also set up the server and listen to a particular port. Then that is your socket server, right? This is your application. Socket server. So your socket server simple Python program is not quite different from Oracle port usages. The setting up the ports or sockets remains the same. So address port sockets, like apartments and mailbox, these are analogies. So what we do, right? You are an application, your apartment's building address is the address, your mailbox is the port, the post office is the internet, the socket is the key that gives you access to the right mailbox. How do you choose which port a socket connects to? Answer from you. You can choose. How do you choose? You can choose anything. Only thing that you have to worry about is the conflict. If some port is already used, but accidentally if you use it, then your program is not going to run. So that you have to check the port serviceability and use the ports unused. There's a specific function called the bind. In most socket programming language, it is not only the function used in Python, but C languages, any other languages. If you do use socket programming, then you use this bind function. So bind function needs to associate and reserve a port for use by the socket. So if it is in C programming, then it is like this. Integer status equals bind. Bind function needs socket ID and port number and size. Okay, there is ampersand. This is dereference in C programming. So status needs to describe error or -1 if a bind fails. And then socket ID is an integer according to socket descriptor. Well, we're going to use a socket descriptor. So add address port. So there's a struct type of address, socket address. Struct is a C language, right? Or Swift language. The size of the address port structure. Bind can be skipped for both types of sockets, when and why. Socket, some of the bind can be skipped depending upon the type of sockets. For example, TCP or UDP. Okay, skipping the bind. Socket diagram, then we don't need, right? If only sending, no need to bind. The OS finds a port each time the socket sends a packet. If receiving, then only if we want to receive, then we bind. Other than that, we may not. Socket streams, which is TCP case, destination determined during connection setup. So in socket stream, you need to do one additional steps, connect. Okay. Don't need to know port sending from during connection setup. Receiving and is as informed the port. So you can see that in your programming. Connection setup. If it is a UDP, in other words, if you want to use this type of sockets, sock diagram, which is the case of UDP, you do not need connection, right? You do not need a connection. Only connection occurs between the two kinds of participants in TCP, and there is a connection passive and active. Connection is passive because it needs to wait for an active participant to request connection, and therefore it can be active. You can see the active and passive. If there are multiple requests from a client, then connection is quickly active. If server, TCP server cannot be active enough to serve all the requests because of overwhelming request, then that is denial of service. So you can see that denial of service if you, once you set up server and client, and then request from your client, so that you can simulate whether your server denies your request. You cannot do that in manual. You have to run your client program by another Python program.
It returns an integer. Int size.
Where are you?
On the line. Int
Oh.
size equal bind. The function bind returns an
So
integer.
there's a C.
Returns an integer.
Yes, C program.
And what's the value of this integer? It can be -1 or what else? It can be 0 and 1.
We are talking about this. This is a sock ID, right?
Yes, like I did.
It's a status. Status is different. Status is
Series is what
if
the
it's
function
1,
is.
0.
So it's going to be 1, 0, or minus 1.
Minus 1 is if it is a failed, right? Bind.
It's blind.
Right.
So 1 is going to be success and 0 is neutral.
Yeah.
And why do they need to do it? Like why they need to do it before sending and before receiving?
When you try to this bind, then it returns, right? So by looking at this status, you can decide whether you continue to send, or because if it is minus 1, then there is an error, so we have to retry. Retry to bind. Bind is a function, so that although it activates to bind, it doesn't mean that it is really bind. There may be some errors. Then your program needs to identify and make determine whether you want to retry or continue to try until it is completely successfully bound, or forget about that specific port number and try to do some others if your program is for attack program. If your program is attack program, you don't need to stay for one port. You have to, if there's an error, then there's many reasons, right? Errors. Anyway, it is not bind. So move to another port and another port and another port to see if there is an open port to intrude. As I said, you do. Two of you needs to form a team, cyber skill competition, right? You can invite someone else also.
So when is it?
The first kick-off meeting will be next Friday.
We're here in Oslo.
In this room.
What time?
I'll let you know.
We're not doing the proposal this Friday. We're doing the
No, not yet.
This presentation.
No, not yet. We need to see. You guys need to share your interest or topics in your mind, either attack or defend, or simply tech improvement, whatever you do. It's not necessarily purely cyber security. If it is a cyber security, then there's a perfect, but still okay. If anything that you could do to improve some technologies, that is also possible. So we share ideas among ourselves, and then we need to decide the teams. For example, two of you guys express A, you express B, but there is another guy express B. Then you don't need to work with him. You need to work with someone who have the same interest as yours. It's open. Everything is open. And if you need something to buy, not really expensive. If it is not really expensive, then I have a grant so that I can buy some for you to accomplish your work. If you say, "Oh, I want to buy a laptop," then I cannot, right? But for example, if you want to do some network device, if you want to do bind or unbind to find out something, If it's not really, price is reasonable, then I can support. If my money is not enough, then I can also ask extra from other source. So that is possible. Okay. I want every one of you to participate, particularly those who are international students. Then you need to do that. Those who are citizens, then you need to do that. What am I saying about that? Everybody, right? If you are a citizen, then you need to make some work and present that to the federal employer. Then they can hire you. Same thing. You could do as an international students group. You can improve some. My role for that competition is a consultation. It's a free consultation. Free consultation. It's my voluntary job. I love to work with you. Okay? I want to sleep at home, but sleep is not better than working with you. So you guys can come. Meeting time and meeting place, anything is open, so we can discuss. Some of the refreshment is possible. If you want to bring, more than welcome. But my fund can bring. As I said, I have small money so that I can bring. If you ask some expensive ones, I cannot. For example, formal meals. Oh no, I cannot use for me either. Right? But refreshment. If that refreshment help you to think more creative ways. Okay, always possible. All right, so let's take a look at the block diagrams of your work, your coding. Okay, if there is a connection list service, either connection list or connection, you need to create a sockets. You need to create sockets, right? Without sockets, then you cannot communicate with the outside application. Bind. This is the server side. This is client side. So your socket is bind with your socket. A specific program software is bind with a specific hardware sockets. Okay. If you see this, then there is no connection. Okay. Therefore, it is connectionless. So server simply receives from or send to. If you send it to, it goes. If send it to, it comes. There's no connections. It's a small program that we will do a little later. And connection oriented. Look at this. This and the previous. This is a little more complicated, right? Previously, we need to, first thing that we have to do is to create sockets and then bind with the hardware. Right here, the server now listen. ready to serve. UDP, simply distribute. Server does not distribute because there are requests. There's a broadcast, right? Although you do not request, you receive. Let's see. Okay, listen, then you can write, which means send to. Then this guy read it, accept and read it. This continues. Okay. So let's try with connection list first, and then connection. Here, this is the program. Oh, I was working here. My pen needs to be here. Sorry. This has nothing to do with TCP. It's a random number, okay? So think about this. This is one. Socket is imported, and the socket is created. This is socket type AF innet. That is for Windows systems. If you use the Linux, then you may use a different type. And then socket DRAM, this is for clearly UDP, and bind to a port. You don't need to specify, or you can say local host if you want. And the while, what it does is that it simply send. Okay. So message, this guy server receives. This is the size of the data, right? Receives from the port, through this port, it receives. When data comes in, there are two compartments: message itself and address, where it comes from. Okay, so we simply print at the server side. Okay, and then we change it to uppercase to demonstrate that whatever message it returned from the server, it reached the destination and comes from the server. So whatever message that we send from the clients, that is changed to uppercase. And then one thing that we do here, this is one extra. It has nothing to do with the UDP or TCP, but in this case we use the random number generates, and if that random number is greater than 4 out of 0 and 9, then we send out. Other than that, we do not send out. A simple demo. So bind this, that, and then clients, again, this is all we need, sockets, right? This is extra that we check the time, not really necessarily related directly to this client program, but to demonstrate something more fluent. So that we create sockets and then generate message in bytes. We set up the port. This port number is the same as that port number at the server side. So this guy, I want to access this port number. And then I check the start time. And this client send the message to that address, which means to that, this is the address, localhost, to that particular ports. So sending out is done. And what we do here is simply receive to see if the message that we sent out modified at the server side, and what it returns is really what we sent out. So this is the data, right? Data is, which is a message, is returned from this received from. This is a message, and this is the server. So remote server. We check the time, and then we can say this data of ping, like ping pong, right? For ping in range 10, which means I want to make this 10 times of this to see if how much that we receives. That's what we did. As you can see here, two things. Because this is UDP, the type is socket is sock diagram, and there is no connections statements, either client or the server. Okay, so let's try. How can you do this? You cannot do this in Paizo. You can program this Paizo, but execution needs to be done command line so that you can open up multiple terminals, and one terminal you can set up server and another terminal client, and to see if how they are communicating. That's what we need to do. As an example, if I do demo, that is in this way. Okay, so I'm going to bring cubic. Small. And another. Okay. So I'm going to run here the server C:python 36 Python, and then program is called the UDP echo server. UDP echo server. Okay. Run that. So server is right now what it does is that when you do this bind and then it's there's no while. This continues, right? It continues to see if any message from this port that we set up here, right? Right now nothing comes. Then we do here UDP okay, client. Watch. So this client, what it does here is that when I hit enter, then 10 times, right? It creates this 10 times. With no connection. It's not connected. So hit enter here, the client. It's done. It did, the client sent out 10 times, right? 1, 2, 3. So first 3, it receives hello, mercy. See the program here that I said hello, mercy, all small, but returns. What it receives here, server received small, right? How many times he receives? 10 times receives, right? But 7 out of 10 returned. So 3 requests time out. If it is time out, then it is time out. It's not connection based. It's done, right? It took 0 times, which means that fast, right? Almost 0. Let's see. Time. I check the time here and time over there. But if I do here, for example, time dot sleep. Let's see. Sleep 100. Oh no. This is not my program. This is slide. Where is my program? Program is this. So, okay, here. Sleep 100. And then save. So 100 is that long? Is it 100 minutes? 100 milliseconds. 95. Okay, see website. To see if we have Python time sleep. I don't know, there is a millisecond, so it's not really. Okay, this server is still on, I believe. Let's say this is 5. Okay, and I want to see to save it properly to all files and then UDP echo client, save, yes, and then to see if there is, I think server is down. Oh, so what is this? Oh, 5 is too long. So when I set 100, then it is 5 is all timed out. Okay, so I want you to practice this. Okay. So let's take about 20 or 30 minutes to practice this. And then we will do TCP, modify the program a little bit, and then try to do attack. So then we need to see the denial of service of our program. All timed out. It's fine. Okay, let's try. Okay, what I'm going to do is to do TCP program. My server. So my server.py. So this is my server, and I'm going to do my client. All right. So my client is simple. My server, if you see here, there's a connect. Okay. And client, there is also connect. So both client and server are connected. Okay, it should be C for client. It's not really the matter, but for save as, and my client, save, yes, and I'm going to come back here to do, and my server is up and running. And then what I'm going to do is, first of all, rather than this, I'm going to, let's try, because it is not, it doesn't stop, so my client, done, and it is done. I have another version that client and server set up connection and communicate continually. Okay, so that is Saki server and Saki client. So what I'm going to do is to run that. So socket server, I'm going to run that socket server. Here, socket client. And it says, what do you want to say? Look at here, at this, the client, and as a client, this guy, server, listens, right? And then as soon this client try to connect to that server, the connection is made. Okay? And then this guy says, hello how are you? Then it came up here, it receives hello, how are you? And then any response, so that you can say, I am fine, and you. And come back here, it says, I'm fine, and you, so that we can say here, what do we say, right? Whatever you want to say, and it came up here, whatever you want to say, then we can say, oh good. Then it come back, say, oh good. And if we say and, then it ends up both, right? So connection in server and client can already set up, therefore they continue to communicate. The previous ones, there's no, the simple my client and my server is the same program, but there's no message sending and receiving. It's simply setting up, okay? So this is my server. So my server is waiting. And if I do, for example, DoD, denial of service communication, I have here, attack. Denial of service, distributed denial of service. I didn't. Okay. I think they're the same. They're the same. Yeah. This is so what I'm going to do is that attack. Simple D what happens is the connection port number actually refused it. Okay. So it continually accessed, but some of them here refused, right? How many times that we did? Attack us only for 10 times. Oh, this is not. Right? But if we do 100 times, for example, save this. Times already refused. Doesn't matter anyway. Our server is now busy. It's refused, right? So multiple times. So refused. I didn't do much of the communication in this simple my client program. If you see my client, then my client is a very simple program. I'm going to show it to you. To cancel this. My client program, oops, no, notepad, my client. Program is simply this. I didn't do anything, right? See here, connect, and then give me data, and that's it.
What about the port?
Huh?
What about the
Port here. This is
connected
10.
different port. Open the server window, CMD. Another window, CMD. You see the port is 5773.
Oh, this is port coming from here. This guy. This is a port of this guy, client. Yeah, it's not the entering port setup here.
Okay, so the client is connecting to the local host at this port.
This
Port number.
This port number is
the client, the server.
yeah server port,
Okay,
right? So server opens that port, and then client just go through that port, but the ports from the client is not the same as that one. Yeah, of course it's not. Okay. I think this is. Let me see how much that we need to do more. Okay, that's it for today's lecture. All right. Next week, midterm exam. Okay, don't forget to come to your blackboard. There will be. You can see that the test will be on your course material. So you need to come to click on course material, and one of the items in that course material menu, then you can see the midterm exam. And I'm going to send it to you the password that you can get in. And then time slots already posted on your announcement, so that you have to plan it. It'll be a 3-hour test. Total programming, maybe one programming, and all others filling in blanks. And if I ask, what is this, what is that, simple answer is expected. Simple answer. Only long answer. If it is long, then there is only one coding program. For example, define a function that gives you the average of number, whatever number that entered. List of numbers. So it can be 100 numbers, or 3 numbers, or 55 numbers. So you have to count numbers and whatever. Yeah, exactly. That is an example. Okay.
So there will be also the reporting part. No, or just only the thing that we.
No, only Python. Only not the network. This client and server socket program is about networks, right? I'm talking about the programming language Python, which is
okay.
right before. No, not. This is going to be asked you on your final exam.
Oh, okay.
The week after, there's no class.
There's a spring break. Yeah, week. So next week is your midterm, and following week spring break. So we'll meet face to face at Manhattan, the first Thursday in April. Hopefully, at Manhattan. But sometimes something is going to happen here, then I switch.
Ah.
But right now, there's no plan. Probably no plan. Then we'll meet at Manhattan campus.
You haven't really talked about the project. 555 project. Sensors and
We'll talk about that. That's a good question.
Huh?